I want that.
Yep. Okay, EMB. Let's talk about that one first.
That's the one I did?
Yes.
Is it recording?
Yeah.
And these
So,
are the old ones, right?
EMB, tell me what its application is.
The inoculation?
No, that's
Isolation.
that's the application for the street plate. But tell me what EMB is used for.
Just water?
It's just water. It's just water. So if we look at this plate, you can appreciate that there's an organism that's metallic green. You see it? That's E. coli. E. coli is metallic green because of the enzymes that it produces and the way that it reacts with the substrate, with eosin and with methylene blue. So it produces this metallic green sheen. Okay? This one, you can see it's metallic here, but you have to kind of look at it in the light just perfect in order to see it, right? I guess, yeah, it looks really red. Okay? So this is what you'll see on the practical for E. coli.
That's pretty.
The metallic green.
Yep. This other organism here is Klebsiella pneumoniae, and that's a lactose fermenter, right?
Something had lactose.
And this one's a lactose fermenter. This one is a lactose non-fermenter. It's taken up some of the color from the media, but because it's been in the incubator refrigerator for 6 days now, it's taken up some of the color from the media. The other organism down here or up here didn't grow. It's in Enterococcus faecalis. Why didn't it grow?
Because you can bring down that.
What does the media do? So let me remind you.
Inhibits the
Inhibits the gram-positive. So Enterococcus faecalis is gram-positive. Gram-positive. So it's being inhibited. Okay? Any questions?
The other two?
The other two.
Cola? After they cola, which one were they?
So this one is Klebsiella pneumoniae. It's a lactose fermenter. This one is Proteus vulgaris. It's a non-fermenter. And Enterococcus faecalis didn't grow because it's gram-positive. Okay?
That one was the what? The what?
EMB,
EMB?
eosin methylene blue. And this is for the virus group.
It says for water?
Yes.
Yeah. Let's go to Hector-1 enterococcus. What's the application for Hector-1 enterococcus? What does it test for? Stools, and it looks for pathogens, right? So in this case, this is because, remember, this particular medium has got lactose principal substrate, bromothymol blue, pH indicator, and what's iron for? Hydrogen sulfide, very good. Nice job. Extra credit, 1 point on the practical for everybody because Keon earned it. Here, this is Enterococcus faecalis, chescanator. It didn't grow. Why didn't it grow? Gram-positive. Good. The other two are lactose non-fermenters, and they're producing hydrogen sulfide. So in this case, they could be either Salmonella or Proteus. So we have to work them up. See them?
It's a black gas.
So here is somebody's, and you can see here how they've got this black centers in them. Okay?
How has what?
A black
One
center.
of us did that.
See 'em?
Is that mine?
Black.
so.
Okay. I did E. coli.
It's more prevalent here.
Yeah, I think that's yours. Because mine's the red one.
Any questions?
What? Why
Oh, no,
did
this
they
is
call
yours.
out turn orange?
Because it's a fermenter. And listen, on here, because this is a different application, this is looking for pathogens in stool. E. coli is common in stools. It's not a problem. Are you with me? Unless we think that there's something that's really, really bad and we would have to do something else. But E. coli usually is not a pathogen in normal stools. We're looking for Shigella salmonella.
Oh, so if it's in stew, it just means that's what's being wasted.
No, it's poop.
Not,
It's
you
poop.
don't have it.
It's poop. Okay? Okay. Last one is Macanthi agar. So here I think you can see really easily that these two are lactose fermenters. right?
What's that?
These two are lactose fermenters.
Amazing.
This one is a non-lactose fermenter. No red. And this one didn't grow, right? Enterococcus faecalis didn't grow. If you look at it, somebody's put a lot of bug on there, but it didn't grow. Okay? So,
Which one is that didn't grow?
enterococcus, it's a gram-positive, it's not gonna grow.
Oh.
Okay, so listen. So, I don't know if you can appreciate this, but I'm gonna hopefully let you. Can you see
The motility.
that around E. coli, this one, that there's kind of this little cloudy turbidity around it?
Yeah.
You see that? That's called bioprecipitation. And two organisms will produce so much acid that they precipitate out the bile salts and they show up in the media as this cloudy around the colony. The two organisms that do that are what?
E. coli
And
I don't know.
and Citrobacter.
Citrobacter?
Citrobacter.
What is that?
It's a bacterium.
Oh.
It was over there in a little corner. I said, be sure you know that. And nobody paid attention. Happens sometimes.
Professor,
Okay, yep.
what does the bio?
I don't want to know. I mean, I don't know.
Oh,
I don't know what
okay.
I'm trying to say.
I
But I
don't
don't
have
know.
autocorrect on here.
See that? See
It's
that
on her
little
video.
cloudiness around the
Oh,
colony?
okay.
I don't know what I was trying
Uh-huh.
to
E.
say.
coli and Citrobacter do make bioprecipitate. Okay? Any questions?
Citrobacter what?
Freundy. Prions is for you.
Don't you have this so at the edge?
Yeah. Oh, sorry. Bacteria, that's for you.
What was this for then?
What's that?
I think I did this.
Just so that you could look at the organism in all its glory. Okay.
Oh man, that was just it was.
So
just
listen,
me and
don't do it yet. Don't do it
Victoria.
yet. We're gonna go ahead so we can save some time because I want to have at least 20 minutes to review. Okay. I want to go ahead and talk about the stuff we're gonna do today. Okay. So it's the gram-positive lab, and this is the Staphylococcus lab. So Dr. John has written some stuff on there that is doing some stuff here.
Oh wait, so you didn't write all that?
I wrote almost everything except the stuff that's really big and kind of fluffy looking.
Oh yeah, you could tell the difference
Yeah.
for sure.
Look how pretty that is.
So
Look a little more.
let me just explain this stuff real quick.
Oh yeah,
So
we saw that.
if we think about the staph and the micrococci, they're gram-positive cocci. They're found, staphylococci are found in clusters. The micrococci are found in tetrads, foursies. Okay? They're catalase positive. All of the staph, all the group of organisms that belong to the family that the staph belong to are all catalase positive. Okay? So I'm gonna show you what a catalase test looks like. It's that second right up. The catalase test, yeah, the catalase test breaks down hydrogen peroxide. It's an enzyme that breaks down hydrogen peroxide. And when it breaks down hydrogen peroxide, it liberates it to oxygen and water. Okay? And the oxygen gets liberated so that it's violet. So, Miss Carolina, will you hand me the organisms that are on the table?
You said it breaks down hydrogen.
Oh, there are no
and water?
organisms on the
Oh
table?
yeah, we have them. We moved them because we're cleaning the
Oh, okay.
table.
Where are they?
We moved it by the computer.
Can you bring them over, Miss Asada? Okay, yeah, that one's good. Okay, so what I'm going to show you is I'm going to take Staph aureus. Be my witness of Staph aureus.
Yeah, it's definitely.
So I'm going to take that, and there should be a rectangular box
Why are
somewhere.
those looks different?
Huh? Because these are, I don't have to flame them,
Oh,
and I didn't really want to suit up all the way.
There's no.
that's
No
smart.
rectangular box?
We need more of those.
No, because they're very wasteful.
Like that?
No. Hey, do
No, I like the whole
will you hand me
flaming
one of those
process.
rectangular boxes?
I feel like I'm grilling.
Biohazard, yeah. Thank you, sir. He was full of muscles. Okay, so look, I'm gonna go in here and be my witness. I'm gonna take a little bit of the organism.
Witnessing.
See it?
Yep.
Okay. And I'm gonna touch it, and so it's gonna bubble like crazy.
Oh wow.
That means that the organism has the enzyme system. The enzyme system breaks down hydrogen peroxide to water
Oh, that's what it is.
and to oxygen. And the oxygen is liberated violently. Okay? If I take an organism that doesn't belong to the Staphylococcus family, like for instance, Streptococcus pyogenes, be my witness, that's Streptococcus pyogenes.
Pyogenes?
You gonna use the same one?
The back end of it.
Okay.
I don't like to be wasteful. So I'm gonna come back in here and I'm gonna grab, look, be my witness because Lakeisha's watching.
Yeah.
She's gonna tell me in a minute, what's my objective?
I'm dead.
So now I'm gonna go ahead and put this on here and you'll notice there's no bubbles.
Nothing.
It didn't break down nothing.
No cloud.
Therefore,
Enzyme system.
Therefore, the catalase test is a beautiful way to differentiate the Staphylococci micrococci group from the Streptococci enterococci group. Okay? Good?
I think, yeah.
It's really easy to do. Okay?
No, it's not.
Yeah.
Strep and staph is the way we typically talk about them. We just say staph and strep.
Staphylococcus
Okay.
meningococci.
Questions?
That's
All right.
it for that.
For that test, that's it. You don't have to do that. You can just take a picture of this and put it in your lab report and that'll be good. Okay?
That's for that one.
There are 3 other tests we're going to do, and one more that I'm going to do as
Can we hold it?
I'm going to do one more as an example. First thing we want to look at is called PEA. PEA is known as phenylethanol agar or phenylethyl agar. It has alcohol in it. So it is going to allow gram-positive organisms to grow, and it's going to inhibit gram-negs, but not kill them. Therefore, you should know this for the practical, the PEA has to be fresh every time. Okay? Because if you use an old one, the alcohols that are in it, the ethanol and the phenols, will volatilize, they'll be gone. So it's only going to inhibit the gram-negs for a short period of time, and once the alcohols are gone, the gram-negs are going to start growing. We do this because the gram-negs grow faster, and the gram-positives grow slower, so this gives the gram-positives a chance to actually be. Okay?
The gram negative.
Inhibit.
A lot faster.
Gram negative. Gram
Are
negative.
inhibited
Inhibited.
by this plate.
Okay.
So it's a selective medium.
And they grow
It
faster.
selects for gram-positives, but inhibits gram-negatives, but it doesn't kill the gram-negatives. It just
Oh, okay.
slows
Yes,
them
I
down.
remember reading that.
It
Okay.
just slows them down. Okay? Good?
Yeah.
So you guys are going to take this, you're going to divide into 3, you're going to put 3 different organisms, and then we're going to look at the results next time. Okay? Second test, my favorite, blood agar. These are homemade. Look how beautiful they are.
Wow.
Is it human blood?
No, sheep blood.
Oh.
You didn't read that. You didn't read the lab manual.
I'm joking.
Right away. No, just kidding.
That was a quick response. I'm just joking.
Yeah, that means I'm true. It's
Okay.
true. Man.
So, there's about 5%, sometimes as low as 2%. But look how beautiful. This is a big skill to have this, because if you pour the blood in when the media is too hot, guess what you make? Chocolate. You make chocolate agar. Right? So remember, chocolate agar doesn't have Hershey's. It's just caramelized blood. It's just blood that's been degraded.
That's crazy.
Right?
Yeah.
Isn't that cool?
I mean, it is.
So on here, this is going to be an enriched. Why is it enriched, Cheskinator? It has blood in it. It's also going to be differential because it's going to differentiate based on the toxins that are produced by the microorganisms. Some organisms produce what we call a green zone around the colony. That's a partial breakdown. We say that that's alpha hemolytic.
I thought that was beta.
Beta is complete breakdown,
Okay. Oh, that's the.
and it produces a clear zone around the colony.
Okay.
Beta hemolytic. And then some organisms don't do anything,
And that's gamma.
and that's gamma. Gamma really means no hemolysis, right? So it's red around the colony. Okay, so you're going to take this, you're going to divide it into 4, you're going to put 4 different bugs on there. Angela, will you do a 4-quadrant streak with Streptococcus pyogenes? Okay? I'll give you a different blood plate.
Oh,
Okay?
isn't it?
Any questions about blood?
Cynthia, this yours?
Oh, I thought it was yours.
Somebody called it. His name is Spam.
Oh, it's still recording? Oh, okay. I thought.
Okay, so Last plate before we go on to do the last demonstration.
Oh, yeah. It was good.
This is mannitol salt auger. Mannitol salt auger is a very powerful tool. It is selective and it is differential.
Both?
Both. So this particular plate has phenol red as the pH indicator. It's got 7.5% sodium chloride, which inhibits everything unless you're a halophile. Cindy, what's a halophile?
Salt living.
It loves salt, right? So up to 10%, we're gonna put 7.5%. It's gonna stop everything except the staph and the micrococcial growth because they're halophilic, okay? So if they're growing on this plate, they're halophilic, therefore they're, by definition, they're a staph or a micrococci. Good?
That's what makes it, that's how you know if they're staph or mycococcus?
On this plate,
Okay.
okay? So if they're on this plate, if they're growing on this, there's a staph or a micrococci. Nothing else will grow.
So
Okay.
this is where we will see like the strep throat and...
Can't see strep on here. That won't grow on it.
Oh, I'm thinking...
Staph
okay.
and micrococci, okay?
Okay.
So what you're gonna do is you're gonna divide this plate, you're gonna put several different organisms on there, we're gonna look to see. If you come back and you have a colony that has yellow around it, that's a mannitol fermenter, and by definition, it's Staph aureus, because that's the only one we have that's a mannitol fermenter here, right? Mannitol is a substrate that we differentiate on its ability, on the ability of a microorganism to ferment it. If it's growing on here, but the media is pink, it's growing, it's a staph or a micrococci, but it's not Staph aureus. And we want a really quick way to differentiate Staph aureus because it's a major pathogen for everything else.
And we can tell Staph aureus too because of the golden color, like the aureus.
The fermentation,
Okay.
okay?
But it also does that on other plates too though, right?
What do you mean?
The Staph aureus, it also shows that golden color on other plates.
Oh, I see. By definition, the colony is golden, but the media will be yellow. It's gonna be like that yellow,
Oh, okay.
okay?
Mustard.
Okay? This is the plate that if you wanted to test your nares, I'll get another plate if you wanna do that.
Oh, yeah. You
We can draw little wheels and then you can just, and put it on there if you wanna do that, right?
see if we're carriers or not.
See if you're carrier Staph aureus. We can do that if you want. Okay? Good? We have to be cognizant of the time because now it's getting close. Okay?
Yay!
Hold on. So the last thing we're gonna do is we're going to do an antigen antibody reaction, a fast rapid test for Staph aureus. So you'll notice here on this little card, I've got Staph aureus and Staph epidermidis, right? This is the reagent. It's IgG that was made in rabbit, and then it was bound to plastic, right? So if you will, if I am the, don't go away, stay right there. If I am the antibody, put your arms on my, put your hands on my shoulder, and he's the latex. I am now the antibody, and he's bound to me. Are you with me? So if I come in contact, okay, you can let go. if we come in contact with the antigen, it's going to form all this agglutination. You're going to see this plastic kind of clump up. So what I'm going to do is I'm going to take the reagent. I'm going to put a drop or two on the Staph aureus side. I'm going to put a drop or two on the Staphylococcus epidermidis side.
And you didn't just transfer stuff from the tip of that from one organism to the other on that?
One more time.
When you touch the organism on the...
It's not on there.
It's not an organism. This is just the, this
There's
is,
an organism on the...
no, not yet.
Not yet?
I haven't put it on there
Oh,
yet.
okay.
Look at the Cheska. She's like making sure I do things right. I love it. Okay, so I'm gonna come in and where is it? Oh, be my witness. That's
Aureus.
Staph aureus. So I'm gonna go in here. I'm gonna take a little bit off. Watch. Tell them there's a little bit.
It's a little bit.
And I'm gonna mix it in here.
And it's gonna clump up.
Now hold everything.
One of them is...
Just wait. Okay.
Get those
Now,
little specks.
I'm gonna go in and say Staph epidermidis.
Staph
I'm gonna
epidermidis.
take a little bit. Watch it. Watch it.
I'm watching.
Down look too close to the other end, crossed up.
Oh, is Lakeisha still making fun of me using both sides?
No, I'm hurrying.
This is Riverside. This is Riverside. We can't afford all this stuff all the time.
We can't afford all that stuff.
I know they can't afford paper either. We got in trouble for printing.
I'm gonna take this and I'm gonna give it a little shaky poo. And look at the magic.
Yeah, I can't see. Oh, the clearing. No, I don't know.
Clumping.
Oh,
The
the clumping.
rigidity?
You see the
Clotting?
rigidity? No,
Yeah.
clumping.
Oh, clumping.
You see
It's
it?
because I saw the
Augulation.
ring of the.
Agglutination. That's the way you say it.
Oh,
So
I
this
see, I
is
see.
positive. This is negative. Okay. How long did it take for that to happen?
Seconds.
Yeah.
10 seconds.
So anytime you go to the doc and they like wait 20 minutes before they give you the result,
They're lying.
they're just milking it for the money. Are you with me?
Yeah.
'Cause
I'm
it
gonna be like,
doesn't
and don't
take
milk
that
it
long.
this time. Because it only takes a few seconds.
Can you get it? It's the antigen antibody reaction. Okay.
Did you say something with there's plastic in it though?
So the plastic is the
I don't even know
latex
where
that
that goes.
allows us to be able to see the clumping.
Oh, it is.
The antibodies are bound to the latex.
Are these the same ones? Like, are these similar to the ones that we test with the blood
wait.
type?
Similar.
Okay.
I think there's a different
Oh, I
company
think
that
it's
makes
this
that
one.
one.
The bottom? Oh,
So-
okay, no.
I bought these in blue, which is my favorite. They also are in white, but then you have to have a dark background because you can't see it on the. And I don't like that part, but yes. So it works really beautifully. So I'm gonna leave both.
And because
the,
nothing happens to that one, what is that?
It's negative.
Negative. Oh, okay.
so this is specific for Staph aureus. Anything else is gonna be negative.
Okay.
If you took it out,
okay,
it doesn't
okay.
belong there. It's,
Really?
no good. It's no longer
didn't-
good.
Contaminated.
It's no longer
You
good.
can take it home.
Yeah, you can get it home if you want.
So they stay
I wasn't
on
thinking to the
package?
These are
kids
sterile. They're sterilized by gamma radiation.
Got it.
Oh. It was a little bit out. So.
It's okay. So microbiologists will always do this. They'll stick these things out and they'll leave them like this.
But
And
they're
then
no
the-
longer sterile.
They are, as long as they won't touch anything.
What about the air?
What
Nah.
about the dust?
Oh, if it touches the desk, yeah. Like this. That's no good. Okay? Good? All right, so let's say 10 minutes to inoculate